Good afternoon, students. Can you hear me?
Good afternoon, teacher. Yes.
Okay. I think now it's time and we can start our today's practice. So now I will be provide your practices. Okay. So let's share my screen and demonstrate the PDF file. Okay, so here we have exercise session 0. I think you started from this exercise session 0. And what was the last example? In first practice? Do you remember? Students?
Teacher, I couldn't attend the first practice. That's why I don't know.
Now we need to begin with the third one. In first practice, you should consider the first and the second exercises. And now we need to begin with the third one. But let me quickly explain first and second, okay? Now, so I think it will be better, yes? We finished exercise 2 with IT 5. Okay, so exercise 2, you are finished. Okay, now let me quickly explain what is it and what we have in first and second exercise. So in the first exercise, we need to define the vector and type the following Matlab instructions to understand what does it mean. So for example, how to give a vector here. Let me open my command window of Octave. We said, so there's a little differences between Octave and Matlab, so we can use Octave because of this is free version. So let me clear all of them. To clear, you will enter CLC. Okay, now let's define this vector X. So in this form, X is in square brackets from 1. So it means the first element is 1 here. The last element is 0. This one is the last element. And what does it mean? This minus 0.1. This is similar with the progression, arithmetic progression in this case. So we will go to the down with 0.1. Each time we will subtract 0.1. For example, in the first case, let enter and you can see the result. So the first one will be 1, then the second one will be 0.9, 0.8, etc. till 0. Is it clear? So this is how to give the vector. Now let's show the next example and what does it mean, this one now. Let me copy and to be quickly. So what does it mean? If we give in square bracket, so vectors and matrices we will give in square brackets here. You can see in square brackets. And colon, it means, so 1, if you write, well, for example, 1 colon 5, it means it will be 1, 2, 3, 4, 5. Automatically add 1. But in this case, we give this value, it is minus 0.1 until 0. Here it's continued. So, but in this case, we have parentheses, so we have brackets here. So round brackets. But inside of these round brackets, we have square brackets. So what is it? If it's square brackets, it's again the elements of our vector. So here, this is selection. If it's with round brackets, it will be selection. So here we need to select first column, fourth column, it will be this one, and third column. So we will get 1, 0.7, and 0.8. You can see the answer. Is it clear?
Yes.
So this is practice lesson. This is laboratory lesson. So I need your reaction. Okay, you need to attend to this class. Okay, so now next one here, the same one. So, but in this case we have zeros. What does it mean, zeros? So zeros is, in this case, 1, 2, 7. It means from 1 till 7th column, and the value of step is 2 now. So it means 1, 3rd, 5th, and 7th. And here you have the last element. So this is 10. So how many columns you will change? You will select now? 1, 3, 5, 7, and 10. So you have 5 columns. And here it's equals to zeros, 1, 5. It means we need to change these elements. So in your X vector, this is 1, 3rd, 5th, 7th, and 10th element will change with zeros. This is zeros, vector of zeros. And what does it mean? This 1 and 5. This is the size of this zero, vector. So 1 row and 5 columns. We need to add here, instead of 1, 3, 5, 7, and 10, just zeros. 0, 0, 0, 0, and 0. Okay, so we'll change these elements. So that's why we need this 5 zeros vector, like this. So this is zeros vector, 1, 5. This is row, this is column. Okay, if it's clear, let me enter here, and you can see the result. So 0, 0, 0, 0, and 0 here. If we change zeros with ones, so not zeros, ones. We have zeros and we have ones vectors. So if we change it with ones, it will be now ones. 1, 1, 1, 1, and 1 here. And other numbers, other elements, you can find using with zeros and ones. Yes? For example, if you want 5, it will be 5 times ones, and etc. Is it clear?
Yes. Yes, Professor.
Okay, now let's go to the next one. So, okay, good. Now, here also the same example. Let's try to do at home. This one and this one also. In this case, and it means the last element. So here, last column. And we need to go from the last column till the first column in reverse order. Is it clear? So it will be now 11s and the 10s, 9s, etc.
Okay.
So now define the matrix number 2. So how to define now matrix? So this 2 you will do at home one more time. Now define this matrix. So let me open again window, command window. Let me clear. And to define the matrix, we will use the next command. So A is equals to, I said, so vectors and matrices will give in square brackets. So, and now, first row, it was from 1 till 4, second row from 5 till 8, and third row from 9 till 12. So now, how to write it? You can write it like this: 1, 2, 3, 4, and between each rows we will put semicolon, and then 5, 6, 7, 8, semicolon, 9, 10, 11, and 12. So this is matrix. But you can give in this case by other way also. So here, for example, this is from 1 till 4, the first row. Yeah, we have low from 5 till 8, from 9 till 12. So we can change this comment with 1 till 4. This is till. Is it clear? This if you put colon here, it means till, until. So then semicolon. I said so each rows we will separate with semicolon, and from 5 till in this case 8 semicolon, and from 9 till 12. So you will get the same one in this situation. Okay, and now let's work with this matrix. Here we can find size of this matrix with the command size A. It is 3 by 4 matrix. You can see here 3 rows and 4 columns. Or you can find this kind of product, but this is not product of matrix. This is product of corresponding elements. You can see here 1, 4, 9, 16. So it is 1 times 1, 2 times 2, 3 times 3, 4 times 4, etc. You can see here, this is not multiplication of two matrices. This is multiplication of elements, corresponding elements. Okay?
Okay.
Now, let's continue. And the next one, this is B is A times A. Let's check it. So now this is, if we give this dot, this is element multiplication. If we give without dot, this is just a product of two matrices, multiplication of two matrices. And do we get here answer? Question? Yes or no? We don't get here answer. Why? Because of this is 3 by 4 matrix, and we multiply it against 3 by 4 matrix. Is it this is impossible? Yeah, because of it should be the number of columns should be equal to the number of the rows, the second matrix. Yes.
Yes.
In this case, 3 by 4 times 3 by 4. This is impossible. This is impossible. It should be m by n times n by k. And then you will get m by k matrix. Yeah?
Yes.
M by k matrix. Okay. Now in this case, it's impossible. So that's why here error. And the written non-conformant arguments, it is 3 by 4, operation 1, and operation 2 again 3 by 4. This is impossible. Now, let's continue. And the next one is this is A transpose, A prime, this is A transpose. And now, is it possible now? What is transpose? We will change rows with columns or columns with rows.
Yes, it's possible.
This is possible because of here we have 3 by 4 matrix, but when we transpose it, it will be 4 by 3 matrix. Yeah. And we will multiply it to 3 by 4 matrix, and we'll get here 4 by 4 matrix. Is it clear?
Yes.
Now let me give it again, and you will see the difference. So now I want to, and this is the other one. So like this, not A prime. Now, is it commutative or not? So here now, transpose. Now, is it possible now again? So you have 3 by 4 matrix.
Yes.
3 by 4, And here again 4 by 3 matrix, yeah?
Yes.
So it will be 3 by
3.
3 matrix you will get, yeah. So let me clear. 3 by 3 matrix you will get. So, okay, now, here we have this kind of example. Can you explain this one? Which one, Shazad? Okay, so this is transpose of matrix. Let me open one more time. So this is transpose of this matrix, and when it transposed, we have 3 by 4 matrix, but after transposing it will be 4 by 3 matrix. We change rows with columns. This is transpose of matrix. And then when we're multiplying by 3 by 4 matrix to A, this is A, this is A transpose. And then we get 4 by 4 matrix. Okay? Is it clear now? Okay, so let's continue. And here also the same situation. Now, let's find this one. So this is again selection. We'll select from A matrix elements 1 till 2. It means, so the first one before comma, this is row. After comma, this is column. Row and column again. So 1 till 2, it is first row and second row. 4, it means fourth column. Let's check it. So you have a matrix, and so here, first and the second row and fourth column, it will be these elements, yeah? 4 and 8. This is selection. Okay, and now we have this kind of operation. So no, let's do this one, and I think then it will be clear. So here you can see this is column. It means all rows. So all rows without changing. And the second part, 2, 4, it means what? Second column and fourth column. If we have 2 or more columns, number of columns, we need to write it in square brackets. If we have just one, like this, yeah, we'll write directly 4. If we have more than 1 columns, so we will write it in square brackets. This is again selection. So we will select all rows, and only fourth and second and fourth column. So it will be this column and the fourth column. Is it clear?
Yes.
So let me demonstrate the answer. So here you can see 2, 6, 10, 4, 8, 12. These ones here. These ones. Okay. Now, let's continue. So this is again selection. This is again selections. You can try to do these kind of examples at home. Now, next operation, this ones. So equating elements. So here without equality, there's a mistake. So without equality here. So A32, what does it mean? A32, it means third row and second column. Third row, second column. This is 10, yes? And now we need to equating this element with A11. A11 here is first row, first column. This is 1. So it means instead of 10, here should be 1. We will replace the element. You can see here 10 now will be 1. So we will replace this A3, 2, and 3 with A11 entry. Okay. Now, this kind of example now. So A1, 2, 4. It means from 1 till 2 and rows here and fourth column. So 1, 2, so first row and second row and fourth column, and zeros should be here. 2, 1 because of 2 rows and 1 column here we have here. Yes, size of zeros now 2 and 1 because of 2 rows here and 1 column here. That's why 2, 1. So we will replace this element with zeros. This 4 and 8 we need to replace with zeros. Check it. Yes. Now, one more important thing. Here you can see 1. So this Matlab program will work with the previous command, with the previous operation. So this is not from the given A from the beginning. Yeah. Here it was 10. Now we change it, this 10 to 1. And now when we compute this A, it's working with this now matrix now, with the last one. Is it clear? To get
Yes.
the correct answer, you need to enter one more time your A matrix and work this matrix then. So if it's clear, let's continue. So the next one, it is just operation. Again, we need to replace the element A2 column. So it means second row and all columns here. And try to do this example also at home and understand the meaning of this example. So it was the brief explanation of the first lesson. So now we'll start the new exercise number 3. Okay, here define the matrix again. A is from 1 till 6, from 5 till 10, from 9 till 40, and from 15 till 20. So we need to write this matrix firstly. So how to write this kind of matrix here? So let me clear. Now let's define this matrix. Here you can write as A equals to in square brackets. And now
from 1 till 6.
Yes, of course, from 1 till 6. From 1 till 6. Then
Column.
Yeah, semicolon.
Semicolon.
Yeah,
5.
Then 5 to 10. Semicolon. And 9 to 40. Yeah, and the last one was 15 till 20. Like this, yeah. Correct. In square brackets. So now, if we enter, so we get the same matrix with the given one. So now we will work with this matrix. And now, assemble the matrix B made by the columns of A in reverse order. So how we can write here this one? Let's try to write me on chat the correct command for this A case. So we did I understood here the for vectors. Now you need to give it for matrix in reverse order. It means firstly it will be 6th column, then 5th column, 4th, 3rd, 2nd, and 1st column. We will give our matrix in reverse order by columns. Okay? Is it clear, students? So try to write it on chat. Try to write on chat the command for this example for A case. So do you have any other idea here? So when we choose, for example, transpose of this matrix, for example, here was Charles dot, but in this case, we cannot do it because if we do transpose, it changed us just columns with rows. So you will get now 6 rows and 4 columns. But we need to find the matrix B made by the columns of A in reverse order. So to do this kind of matrix here, let's do it together. B is equals to A. Yeah. Now we need to select. So rows will be without changing because of here written only we will change columns, order of columns. So that's why we'll put here column. It means all rows. Look here. You can write here from 1 till 4 also because of here we have 4 rows, or you can write just column. It means all rows. And then comma. And now as column, we will consider the next one. So we begin from the last column. So to write the last column, you can write here 6, or you can write here and. They are same. So if you know the number of the last column, you can write this number. For example, in this case, you know, here we have 6 columns. But if you have more columns and you don't know how much them, so you can write just and. So and means the last one. And now column. So, however, we need to go to the reverse order. What should we do? -1 step. So it means
yes, minus
till
1.
1. Yeah, till 1, but -1 step. It means from the last one till first one going reverse order. Is it clear? So let enter and show the results. So here you can see 6, 5th, 4th, 3rd, 2nd, and 1st column. With it, we changed our matrix to the new matrix B, which is reversed by columns. Is it clear here? Do you have any questions? Please,
Yes.
your questions, if you have any questions.
You select, you put this semicolons. It means from the start, yes, till the end.
This one, you mean?
Yeah.
This is colon, semicolon, this is this one. So colon,
Yeah,
it means all rows. The first argument, this is row. The second argument, this is column. So
yeah.
this one means all rows. You can write here, I said from 1 till 4, but to write quickly, you can write just, you can put just colon. It means all rows. It select all rows, but as column, we will select this kind of columns. So beginning from the last one till the first one, going to the -1 step.
Yeah, now clear.
Okay, good. And now, let's consider the next example. So sample the matrix made by even columns of A, B1. So now we need to find the matrix only made by even columns of A, not all columns or all rows here, only even columns. How to get such kind of example now? Do you have an idea?
Yes. Can we make it ourselves? Give us
okay, do it together. So B is equals to new matrix. Let again selection, yeah. So again selection, I said selection in round brackets in parentheses. So here again we will change just columns, not rows. So again we will put column instead of rows, yeah, all rows. But now we will select columns, only even columns. The first even column is which one? Second one, yeah.
Second.
We will select this column. column, this column, and this one. So we need 1, 2nd, 4th, and 6th. So you can write it by hand. So for example, like this, in square brackets, 2nd, 4th, and 6th. If you know the number of columns, and enter. So you get the answer. But you can give automatically. So here we put colon, then now beginning from 2, because of the first even column is 2, and we will move 2 steps. 2 step, correct, 2 step, and till the last end, correct, and it will be again the same answer. Is it clear? So I think it's very easy to understand here. So we put, instead of rows, column, because we don't have any changes in rows, but instead of columns, we'll put here 2, and step is 2, and the last element here. Is it clear?
Yes.
Okay, now let's continue. And next one, assemble the matrix made by odd rows. How to do it? Do you have an idea here? It's same with this one. Now, not columns, now rows just. What will be here? B, yes? Do we have answer in chat? Correct, but here we will write the last element, and.
Yes.
Sorry, it's again. Wait. Let me write here. B equals to A, then 1, 2, and then all columns, yeah? You get the answer here. Yeah, now it's correct, your version also. So you cannot change your comments. You need to write one more time and change. So here you cannot change. Is it clear? 1, 2, and all columns. I think now it's clear. So next one, assemble the matrix made by rows 1, 4, 3 and columns 5, 2 of A. Oh, sorry. So how to write here? So here we have rows 1, 4, 3 and columns 5, 2.
Selection and the square brackets, mean?
Yes, of course, selection. A. Yeah, and here in square brackets, of course, in square brackets, there was 1, 4, 3 as rows here, 1, and we will separate it with space 4, 3. If you write without space, it will be just 43. Okay, so 1, 4, 3 and the comma, and then columns. Columns are 5 and 2. 5 and 2. So in this case, it is, we obtain here the matrix assembling first, fourth, not this one, this one. First, fourth, and the third rows, and the fifth and second columns. So here you will get fifth and second column, and the first element will be this one, this fourth, this one, and this one. So let's check and explain. So you can see 5, 19, 30, 2, 16, and 10. We just selected new matrix from given matrix A. Is it clear now?
Yes.
Any questions, please?
No question.
Okay, if you don't have any questions, let's continue. And now, assemble the vector made by the diagonal elements A, K, K, where K from 1 till 4 of A. So here we need to find diagonal elements. And when we can find diagonal elements? When our matrix is a square matrix. Yeah.
Yes.
So, but in this case, it's not square matrix. That's why we will consider just first 4 columns here. First, however, we have 4 rows and 4 columns. So, and then we get here as diagonal elements, these elements. 1, we consider just this matrix. 1, 6, 11, and 18 will be. And how to find these elements now? So we can obtain these diagonal elements with special command diag of A. Yeah, this is diagonal elements of A now. It will be automatically choose the diagonal elements from the beginning. Is it clear now? Okay. Now let's consider the next example. Let's return to the first part and explain me what will be here in this situation. Let me copy and put to the command window. And who can explain? Sorry, our A is now matrix, sorry. Let me one more time. A matrix in this forum, yeah. So where is our A matrix? Not this one. Our A matrix is this one. So, and now let's copy and work with this matrix. So who can explain me what kind of changes we have here in this operation? Please give your answer. So here you can see A2 and column. It means second row and all columns. Yeah.
Yes.
Yeah, this one. And now we need to change this row second row with this element. Here we get, after arithmetic operations, we get the element. So how it will be? A to this one, so this element. Let me draw. So this one. And now, firstly, let's divide A to 1. A to 1, this is A to 1. This is 5. Yeah?
Yes.
And then A11, it is 1. So 5, we will divide to 1. It will be here 5. Yeah?
Yes.
And then multiply this 5 to
By
the A1 and the column. It means first row and all columns to these corresponding elements. Is it clear? For example, 5 times 1, it is 5. Then 5 times 2, it is 10. 5 times 3, it is 15. And 5 times 4, it is 20. Sorry. Yeah?
Yes.
And now we need to subtract from the second row this corresponding elements. So here, the first one will be just 5. Now, 5 minus this 5, it is 0. 5 minus 10, it is minus 4. 5 minus this 15, it is minus 8. And 5 minus 20, it is minus 12. That's why we have these elements here. Is it clear how kind of change we have here?
Yes.
Okay. Can you continue now? So if it's clear, we will continue. I will clear all. Now, number 4, use a Matlab command diag to define A by N tridiagonal matrix B in which the main diagonal elements are equal to 5, while the sub-diagonal elements are equal to -1, and the super-diagonal elements are equal to 3. First of all, we will do this part, and then we will do the next part. So what does it mean? What is the tridiagonal matrix, 10 by 10 tridiagonal matrix? It means, let me try to draw here matrix. So it means this kind of matrix, 10 by 10, and we have three diagonals. This is main diagonal. And we have sub-diagonal here. And we have super diagonal here. And other elements are zeros. Okay?
yes.
So this is tridiagonal matrix. So the main diagonal elements should be 5, etc. And the super diagonal is 3. Here's 3. It should be the diagonal upper 1, then main diagonal. Okay? This is 3. This is 5. And the subdiagonal ones are -1s, -1, etc. -1. Is it clear? Do you understand what kind of matrix we have?
Square matrix.
Okay, let's now build this kind of matrix. And let me write here using command diag, of course. So to build this kind of matrix, first of all, we will build each diagonal matrix separately. So firstly, main diagonal matrix, and to build main diagonal matrix, we will do this operation D, denote by D. You can denote by any letter. D, diag, D, diag, and then, however, the elements of the main diagonal should be 5. So here 5 times once. Do you remember? Once. And what size here we have? However, we have 10 by 10 matrix. So it should be 10, 1. Because now we have here, let me again draw this one. So 5, 10 fifths. So 5, 5, etc. 5. So we have 10 rows and 1 columns. So this is the inside of this diag. And when we use the common diag, it will build automatically this kind of matrix. 5, 5, 5. Other elements are zeros. Okay? Is it clear?
Yes.
Let's show. So you can put here semicolon. If you put here semicolon, the result will be saved, but not show the result. And you can do the next one. But if you don't put here semicolon, it shows the result. You can see the diagonal matrix here we have. Is it clear?
Yes.
So this kind of diagonal matrix we have. And now let's build the next matrix. Let me hurry up because we have. So now SD, for example, this is subdiagonal, for example, and now again diag. And now subdiagonal elements should be -1s, yeah? Yeah, -1s. So now -1 times 1s, yeah? And then what will be the size of this subdiagonal matrix? We can say
9 by 1.
9, 1, correct. Why? Because of this is here we have, yeah? And how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 elements here. Less than 1, so here 9, 1. And one more thing here. However, we need to build subdiagonal matrix. Here we will add again -1 because of this step. So we will move from main diagonal to one place down. Is it clear?
Yes.
You can see result here. So without this -1, it will be just main diagonal. Let me write without -1. You can see here. So you can see here 9 by 9 matrix here, and this is my main diagonal. But if we move one place down, it will be now subdiagonal. Is it clear now? Okay, now next one, super diagonal. Let's SPD with the note, and it's again diag. So now they should be equal to 3. So 3 times 1s, and again size will be 9, 1, yeah. And now we have just +1. We'll move from main diagonal 1 to up. Yes, correct. Abdulaziz is correct. So now let's show the result here. So you can see this is now super diagonal. And now what should we do to build our matrix, so this three-diagonal matrix, we will add all of them. So it was D plus, now let's write any new matrix, B matrix. It is equals to D plus SD plus SPD. And you will obtain your required matrix. Is it clear now?
Yes.
Okay, if it's clear, let's continue. And we have the second part of this exercise. Set the elements of intersection between columns 6 and 9 and rows 5 and 8 equal to 2. Set the elements of intersection between columns 6 and 9 and rows 5 and 8 equal to 2. How to get here?
Using selection, maybe.
Yes, of course, using selection again. So we need to change these elements, intersection of these elements with 2, yeah? So what does it mean? It means 5th and 8th column. So it is 1, 2, 3, 4, 5. And the 6 and 9 column, yeah? 1, 2, 3, 4, 5, 6 here. Instead of this 3, we need to replace with 2. And again, 9, 7, 8, 9. Here also we need to get 2. And similarly with the 8th row. Okay, is it clear with the condition of problem? So now let's try to do this example. So again, B and selection, correct. So B, so however we have 2 rows, we will do it in square brackets, 5, 8, yeah, close the square bracket, and then comma, again square brackets, and the 6 and 9th column. 6 and 9th column. And it's equals to 2. Yes? So let's check it. Yeah, we got our answer. So 2, 2, 2, and 2 here. In the intersection of these rows and the columns. Is it clear?
Yes, yes.
So do you have any questions here? So we quickly repeat the first and second exercise also, and then we did third one totally and the fourth one. So the next time we'll continue from this number 5, and here now, so we finish it with vectors and matrices, and now we will begin functions. And the first command, it will be plot. It is graphically represent the function. So we will do these examples. So please give your questions.
I have no question.
Okay. So the next time it is tomorrow. At this time we will continue.
Okay.
No questions?
No. Goodbye.
Okay, if you don't have any questions, thank you for attention.
Thank you.
See
Thank
you.
you, teacher. Goodbye.
Goodbye.